Okay. Yes. Today we are going to learn how to create the clustering with orange. So this example is using the iris data. So let's open the orange. And you know that we have the iris data set in the file. And we know that there are 4 attributes: sepal length, sepal width, petal length, and petal width. And then we have one target, which is the iris. So you know that the clustering is based on the unsupervised learning. What is unsupervised learning? We have data without target. So in this case, we still have the target. Then there's one way, actually, you can select the features that you can use. So if you select, and now, okay, if the iris column in the target, then it means we want to do the classification. Why? Because the iris is a categorical data. Because it is categorical data, then if we put it in the target, we want to do the classification. If we exclude this from the target, then we don't have any target. We can do something unsupervised learning. So I'm going to connect this with the k-means. So k-means, as you may know, we need to determine the k. What is k? It is integer number to represent the number of groups. Okay. Let's say I want to make 2 groups. Then you can fix the number 2. If I want to make 3 groups, then you can change this one to 3. Or in this tool, they give you a range of number. So orange will compute automatically from k equals to 2 until k equals to 8. And there is one measures, or there is one score. We call it silhouette score. Okay. In detail, I will explain maybe in next 2 weeks about what is silhouette score. But for now, we need to choose the value which is closer to 1. Okay. So if the value is closer to 1, then it is the best value. In this case, k equals to 2 is the best value. But do you think k equals to 2 is good? No. Why? Why k equals to 2 is not good? So there will be two kind of reasons. The first, we know that this flower contains of 3 types, but the scores give you 2. It means if we have our knowledge about this kind of data, usually we will not consider this score. We will just consider our knowledge. Because I know that there are 3 flowers, so I can choose 3. So I don't need to think about these numbers. The other reason why 2 is not good, you can check on the result. So you can make the data table. When you create the data table, you can see every data. Now there are 2 additional columns. The first column is cluster and the second column is silhouette. The cluster means it is the group where every data is similar. So if you still remember, our first data about this battery and camera. If they are similar, then we make in one group. If they are not similar, we will make in different group. So we know that the row number 1 and the row number 2, they are similar. So we make it into one group. And if you see this one, now we have C2. Okay. Then we will make it also there in the same group. And if you can see from the silhouette score, it seems that the silhouette score more than 0.69 or 0.68, higher than 0.68 is in the C1. Lower than 0.68, it is in the C2. Okay. We can check this result using the scatter plot. Or you can also check this one with the distribution. Let's say in the distribution, so I can check the cluster. Is the cluster distribution is good? No, it's not good. Okay, because this one is lower, much lower than the other clusters. And I can check the scatter plot. In this scatter plot, okay, you can see, maybe you can select this petal length, this is petal width, and then the color, I would like to change it according to the cluster. Now I can see that this one is cluster 1 and this one is cluster 2. Okay. Now it is better to see the original data. We know that the original data, we can also create the distribution. We can create the scatter plot. Let me make the scatter plot for the comparison. Okay. So this is the scatter plot when we have 3 flowers, Iris setosa, Iris versicolor, and Iris virginica. And then I would like to open the scatter plot when it is the result from the clustering. So if I do the comparison, What is the result? We saw that the original flowers, okay, the cluster 1, it seems the same. Okay, so I can say that, yeah, the class or the label for this group is okay. It is the same with the original data. But the cluster here is not good. They are in the one group, but actually the original data is separated into two different groups. Okay. So some data are in between this one. Yeah, I can say it is separated into this group and this group. Meanwhile, when you do with the clustering only two, everything is in one group. So I can say that this k equals to 2 does not represent the original data. Okay. Now I can try to change. If I change this k means with the k equals to 3, then I can check again the scatter plot. And you can see that now almost all the data, okay, so this one is still the same. Okay, we have the petal length, petal width, and then this cluster are the same. How about the other clusters? Okay, the result from this clustering, some of them are mismatched or does not match. Okay. For example, this data is in the Iris virginica. They are in the same group with this, but in this clustering, the blue color is like a kind of outlier. So that's why if we learn from the theory, k-means is sensitive with outliers. Okay. So this may happen. But at least we know that, yeah, many data are separated similar to the original. So we can say that, okay, k equals to 3 represent the most from the original data. Okay. We can have the next, okay, we can do with the hierarchical clustering. What is hierarchical clustering? The hierarchical clustering, it starts with the distance matrix. You still remember distance matrix? Okay. We want to make the distance between two objects. So we can create the distance matrix using distance. There is a widget distances. And when you click this one, you will see whether you want to measure the distance between row or between columns. Okay. So if you measure between rows, then it means like this one. Okay. If between columns, if you check columns, then it means between the value on particular columns. And then you can see the distance matrix. So you already learned some of the distance metric like Euclidean, Manhattan, cosine, Jacob, Spearman, absolute Spearman, person, absolute person, Hamming, Mahalanobis. And I think, yeah, there's another one, Bhattacharya. So there are several distance metrics, but maybe let's just use Euclidean. Okay. And we want to normalize. What is normalize? We want to make the normalization. I think in the Python, in this orange tool, they use the basic minimum maximum normalization. You can check this one using the distance matrix. When you open it, then you will see the distance between objects. So this is the distance between 1 and 2, the distance between 1 and 3, the distance between 1 and 4, and so on. And based on this distance, we can make the hierarchical clustering. As you might know, in the hierarchical clusterings, we can define what is the distance measure. We call it linkage. We learn about the single. You still remember single? Single link. Okay. So we learn in our PowerPoint, the single link means we want to find the minimum between different two groups. Okay. We can also use average. We can also use, there's another way. We call it weighted link. There's another complete. Complete means you want to find the maximum. Okay. And then there's another linkage named what? So you can make the comparison, but in this comparison, there is no such metric. So you need to see from this one. Now I can use any linkage. Let's say I'm using single. You can select this tree manually. So if you select manually, you can just click on this one, and then you can click and you can move the cut line. The cut line means, you can cut tree. How many groups you want to create? Let's say if I move this group here, if I move the line here, then you will see there's 1, C3, C2, C4, and C5. So there are 5 groups. If I move this a little bit here, then we can see that we have C3. Oh, we have one individual here, C2, and we have a lot of C1. So if you have this situation, of course, this is not a good clustering, because one cluster contains only one data. So this is not good. Then you need to select different way. Maybe linkage, single linkage is not good. So you can have another linkage. For example, let me use complete. Okay, in the complete, the data seems to be more, is better in terms of the distribution. But now you can check. You can check from the distribution. So you can continue with the distribution from the hierarchical clustering, and you will see the distribution of the clusters are not equal. If it is not equal, then maybe the linkage is not good. So you can change the linkage. Maybe I will change to what? If I change to what, then let's see the distribution. Oh, now I have only 2. Okay. So here, actually you can select whether you want to select manually, or let's say here, you want to get top 3. Okay, so top n. It means I want to create 3 groups. So if I want to create 3 groups, then I can see here, okay, again, the distribution is not that good. It is not equally the same as the original data. Then, you can choose which one is the best for you by looking at the other approach with the n equals to 3. Weighted, this is the distribution is also not good. Average, the distribution is not good. So maybe what would be the best one? What or the complete? This is the result of complete, and then this is the result of what? Okay. What does it mean by this experiment? So clustering is very subjective. We cannot say this one is better than the other one. Maybe my decision will be different with your decision. Yeah. So it happens in the clustering because every data has their own specification. For the second data, first I thought that I can give you assignment with this, but let's try together. Okay, let's try together. Before I do the second data, I would like to teach you, if we have already this cluster, okay, we have already these 3 clusters. Can I say this is 3 kind of flowers? This is flower 1, this is flower 2, this is flower 3. Okay. Actually, yes, because they represent the similar properties. Okay. So I can say this is the flower 1, this is flower 2, this is flower 3, but I do not know the name. Because I can say like that one, then I can do the classification. So I can make the tree. Oh, before I make the tree, I need to select the column. I need to select the column, and then I use all the features, and the target is the clusters. After I have that selection, so I can use the tree, and then I can create the tree view. So based on the tree viewer, okay, the petal width is the most important attribute to distinguish the flower. So C1 and C3 can be distinguished based on the petal width, and so on. You can also use the same idea when you have the clustering with the k-means. So after you have the k-means, you can select the columns. So I have the 4 features, and then I have the target, which is the cluster, and again I can make the tree. I can make the tree view. So this is the tree result. And now the tree is like deeper than the other tree. How can I measure this performance? You can return back to your original classification. We can make the test and score. So we can check whether it is accurate or not. So I can just give the data here. And then if I do with the cross validation, okay, the result is 94.7%. So here, the classification accuracy is 94.7%. What about if I calculate with this tree. So I can also do with this test score. I can also do with this one. And then, okay. This one is 95.3%. So I can say that this result, the hierarchical clustering, gives a better accuracy. And this mechanism, we call it the self-supervised learning. Did you remember the self-supervised learning? If you look at the classification, self-supervised learning. In the self-supervised learning, we do not have the label, and self-supervised learning is similar to unsupervised learning. The data don't have any label. And what we are going to do is to make their own label or the pseudo label. So the pseudo label means the result from the clusters, we can get the column clusters, C1, C2, C3. We call those as the pseudo label. And after we get the pseudo label, we follow with the supervised learning approach. What is the supervised learning approach? In our example, we use decision tree. Okay. So we did the self-supervised learning. Okay, now let's move on to the second data. Okay. Let's try to make this one together. I will give you another assignment next week. Okay. So you can just pay attention on how you can solve this problem. I will choose the data set AutoMBG. I guess you already know this data. Use the data set. So the AutoMBG, yeah, this is the data about miles per gallon. We know the car information, and based on that car information, I want to predict how about the efficiency of their fuel. So if the car has 8-cylinder, if the displacement is 307, if the horsepower is 130, if the weight is this amount, and if the acceleration is here and the model year is 70, then I know that the MPG miles per gallon is 80. So for this problem, let's see. Use K-means and select the best K. Explain the meaning of the clustering. So I can select the column, and then I can remove this one, because in the clustering, you do not need any target. And after we have this, you can just do the K-means and then check from 2 until 8, what is the silhouette score? So the silhouette score now, the highest is K equals to 2. Then I can say, yeah, the best is 2. You can check the meaning by these two by looking at the scatter plot. When you create the scatter plot, when you want to find the meaning of this cluster, then you need to have like some experiment. Okay? There is no such rule for determining the explanation, but yeah, you need to check one by one. We know that this kind of plotting, scatter plot is for the numerical data. It is not for categorical data. So if you put in the cylinder, even though it is numbers, but the numbers is integer in the particular category. So if you look at this number, the C2, okay, C2, the cluster 2 is belonging to the cylinder 8. The other data seems to be in the cluster 1. So I can say that the cluster 1 is the car with the smaller cylinder than 8, and the cluster 2 is the car with cylinder 8. And we can also see from this displacement, most of the car in the cluster 2, they are high on the displacement. For the car in the cluster 1, the blue color, it is low in the displacement. So that's the meaning. It is only based on the cylinder and the displacement. So you can look at another column. For example, I want to check the horsepower and the displacement. So here you can check the result. If the displacement in this line, then we can distinguish the C1 and C2. So C2 is the displacement which is higher than 260, and the C1 is the displacement which is lower than 260. What about this one? Okay, we can also distinguish this. C2 is the horsepower higher than 110, and C1 is the horsepower which is lower than 110. So we can do that kind of description. Next, let's use the hierarchical clustering. We can use the hierarchical clustering by creating the distance matrix. We call distance. So in this case, I'm just using the Euclidean. And then I will make the hierarchical clustering. And you can change what linkage do you want to choose. Are you going to use single, average, weighted, complete, and what? Now, there's a question. Select the best approach to resolve the clusters. Whether you choose single or complete or average. So which one do you choose? In this case, as I mentioned to you, clustering is very subjective. It depends on the objective of your project. That's why in the proposal, I always ask you, what is the objective of your project? If your objective is, for example, I want to check the MPG, which is higher and low, then maybe I can just select only like 2 clusters, high MPG and low MPG. So if I look at this one, then I can just see this on the two clusters maybe, because my intention is to make only two clusters. If I make two, okay, so if I make two this one, then you can check with the scatter plot or with the distribution. With the distribution, oh, the distribution are not the same between the cluster 1 and cluster 2. Then you can check what is the result if you change to complete. Then you can check again. Okay, this is the result. And then you can check again with the result of, for example, single. Using single, okay. This is also not good. Okay? So it's better to use the previous one. In this case, the result of the clustering, yeah, does not represent any clusters. So I can change to, for example, average. What is the average? Okay, somehow average, complete, weighted, and what, they show almost the same result. So it means you can choose which one is the best for you. Explain the meaning of the clustering. So when you explain the meaning, of course, you need to explain with the scatter plot. Okay, I will just use the scatter plot. Again, you can select the X, you can select the Y, and then make the color as the clusters. And then you can look at the plot. By looking at this one, maybe I can say that the blue color, the C1, is the horsepower more than 115, and the red color is the horsepower lower than 150. What about the displacement? The displacement for the higher part, it is more than 260, and for the lower part, it is lower than 260. Okay. So that's the general way to explain the result. You can also check with the other attribute. Let's say I want to check based on the acceleration, and I want to check according acceleration and weight. Okay, if it is like this one, it's difficult to check, but it is still distinguishable like this one. So the C1, the blue color, it shows that, yeah, it has the high weight compared to the red color. And this data, it seems they have higher acceleration than this data. So that's what we can do to describe this kind of scatter plot. Okay. Next, let the MPG, which is higher than the average, is categorized as high, otherwise low. So I think you still remember. We have the feature constructor. Oh, I still have this one. Okay. So if the MPG is higher than the average, it will be high, else low. So I can make this feature, and then I can select the column. So basically, when you do this kind of thing, so here, okay, the problem now is you need to do the classification. So you need to do the decision tree and explain the tree. And you can have the column, because we just create a feature, which is the MPG categorical. So the target will be this one. And I can do, yeah, let's say if I want to include everything here. Okay, I want to include everything here. And then I want to do the classification, tree. And then I can check the tree view. Because it is too complex, let's make it short. So we have the tree, and we see that displacement is the most important attributes to distinguish between the high and low. And then next, we can do again the self-supervised learning. What does it mean? Using the result of k-means, do classification. So I have the k-means. So after I create the feature, maybe I can make this one select column. So I do not use this MPG categorical, but I will show you something. If I use all the data, I use all the attributes here, and I want to create the k-means. Is it possible? What is the weakness of k-means? What is the weakness of k-means? Ali? No? Okay. One of the weakness of the k-means is it is only for numerical attributes. In this case, C means categorical attributes. Can we use categorical attributes? Basically, we cannot use. But if you connect to this k-means, there is no errors. So you can create this one. So basically, it is not possible, but in Orange, they allow it. So this k-means will be a result only based on the numerical attributes. Even though you have categorical attributes, but they calculate only based on the numerical attributes. And let's say I'm using the k equals to 2, then I can continue. I can continue to make the select column. So in this case, I'm using all the features, and I use the cluster result as the target, and I make the tree, and I make the tree view. Okay. So this one, using the result of k-means, do classification. There is a comment here. Select the proper features. For the classification, you can do with any features. And then do the decision tree. Do you think the tree is the same with the problem 3b? What is problem 3b? This one. So if I show the result, This tree is something like this. This is the tree from the k-means. But the tree from the classification is like this. So is those three the same? It's not. Why? This one shows that displacement is the most important attribute. But this one shows cylinder is the most important attribute. So they are different. Okay. So that's why whenever you do the self-supervised learning, it is very depending on your data, how you can create the self-supervised learning. Okay, any questions?